Hi there. You've reached the personal residence of Mr. Bolel. Sorry I couldn't come to the phone right now. Just leave me a message and I'll get back to you as soon as I can. Thanks for calling. Bye. You're still here? I thought for sure that would have gotten rid of you. But I guess it's for the better because we've got some absolute value inequalities to solve. So the title of our lesson today, Class 3, Unit 3, let's chat about solving some absolute value inequalities. We've spent the past couple days exploring equations with absolute value symbols, but that of course doesn't mean that equations are the only place we're going to find those symbols. So take for example this friend. The absolute value of x is greater than or equal to 3. In the back of your mind, start asking yourself, what might this mean? What is this asking us to find, right? Or what is it asking us for? But before we even get there, remember, right, it can never hurt to ground ourselves in our goal. What does it mean to solve an inequality? I'd pause the video, but you know it so well I don't even have to. To solve an inequality means to make the inequality true. So to solve, again, my goal, I'm trying to make my statement true. Can you find, take 10 seconds, pause the video, some numbers that you could plug in for x here that when you take their absolute value, you'd get something bigger than or equal to 3, something that would make this statement true. Go ahead, pause the video, see what you come up with. Alrighty. Well, our first ones, if we see an or equal to, hopefully some of the first numbers that came to mind for you would be 3 and negative 3. If I take the absolute value of either of those numbers, I would get 3. 3 is equal to 3, so both of these numbers will make my statement true. And if you played around with some other numbers, maybe you noticed, if I take any number to the right of 3 on the number line, so say I take 5, for example, 5 has an absolute value of 5. 5 is greater than or equal to 3, so that is true. And I could keep going anywhere to the right of 3. Say I took 8. 8 has an absolute value of 8. 8 is greater than or equal to 3. 8 is a solution. But I could also, hopefully you found some numbers, to the left of negative 3. Say I took negative 6. Negative 6 has an absolute value of 6. 6 is greater than or equal to 3. I could take negative 7. Negative 7 has an absolute value of 7, which is greater than or equal to 3. So anything to the right of 3, to the left of negative 3 seems to work. But if I try to take a number in between the 3 and the negative 3, say I take this positive 1 here. Well, positive 1 has an absolute value of 1. That is not greater than or equal to 3. I could take 0, right? 0 has an absolute value of 0, which is not greater than or equal to 3. I could take negative 2. Its absolute value is 2, which is not greater than or equal to negative 3. So what we've found here is that if I take 3 or any number to the right of 3, or if I take negative 3 or any number to the left of negative 3, I will get a number whose absolute value is greater than or equal to 3. What does this look like? Ringing any bells for you? What does this resemble? Think back to Unit 2, 5, 4, 3, 2, 1. Well, this looks like the graph of a compound inequality. It's a split. And splits always come from our or statements. And in this case, my two inequalities that make this true, I could be either a value of x that's less than or equal to negative 3, or that's greater than or equal to positive 3. Interesting. So there's a connection between the absolute value inequalities we're going to solve and the compound inequalities that we talked about back at the end of Unit 2. Okay, great. With this thought experiment in mind, let's start to think about how we'd actually go about solving some inequalities. To put into perspective what we're doing with inequalities, let's think about where we're coming from with our equations. If the absolute value of x is equal to 2, take 5 seconds. What could x be? Go. 5, 4, 3, 2, 1. Well, if the absolute value of x is equal to 2, remember, I've got two options. The two numbers that have an absolute value of 2, right? X could be positive 2 or negative 2. Both of these have an absolute value of 2. So that's the answer to my question. But why? Why does it make sense that both of these numbers are my solutions? Well, what this is saying, by virtue of the equal symbol, remember, absolute value is a measure of distance. So this is asking me what question? 5, 4, 3, 2, 7,000. Well, what it's saying is that I want to know what numbers are exactly 2 units away from 0 on the number line. And it turns out that those two answers are 2 and negative 2. Cool? Cool. Now let's take that idea and bring it to our greater than and less than cases. I like to think of these like questions, right? What question is this asking us? Well, take 30 seconds, pause the video, take a risk, take a chance, who cares? I'm not necessarily expecting you to get it. But if I want the absolute value of x to be greater than 2, what do I know about values of x that make this true? Same thing if I want the value to be less than 2. What values could be, or what parts of the number line maybe do I care about if the absolute value needs to be less than 2? See what you come up with. Play around. Who cares? Okay, well, if I want the absolute value of x to be greater than 2, the idea here is that instead of wanting the stuff that's exactly 2 units away from 0, instead what I want is the stuff that's more than 2 away from 0. And on the number line, if I'm thinking about stuff that's more than 2 units away from 0, well, if I've got my negative 2 and my positive 2, that's the stuff that's exactly 2 away. And if I want the stuff that's more than 2 and negative 2, well, I can't have 2 and negative 2, so let's give those closed circles. They're exactly 2 away, or open circles, sorry. But if I want stuff that's more than 2 units away from 0, where on the number line would it need to live? Well, it needs to be either to the right of the 2 if it's getting farther from the 0, or to the left of the negative 2, right, which is going to be right farther, again, from the 0. This, as we saw in our example above, here's our split. So if I want something to be greater than, the absolute value is going to be greater than or equal to, right, I need to be on the outsides of my two cases that I would get from my equal, my 2 and my negative 2. It needs to be on the outsides of the negative 2 and the positive 2. This, of course, results from our OR compound inequality. By the same token, let's say the absolute value of x is less than 2. Well, here, I don't want the stuff that's exactly 2 away. I don't want the stuff that's more than 2 away. I want the stuff that's less than 2 units away from 0. Well, again, if I use my number line as my guide, if I want the stuff that's less than 2 units away from 0, I want stuff on the number line that's closer to 0 than negative 2 and positive 2. Well, if I want to get closer to 0, I need the stuff not on the outsides, but in between the negative 2 and the 2. This, of course, means that when I see a less than symbol or a less than or equal to symbol, graphically, that's going to give me an and statement, which visually corresponds to my sandwich. Cool. So if I'm greater than, I need to be farther from 0, or in other words, on the outsides, my split. If I'm less than the absolute, or if the absolute value is less than, right, then I need the stuff closer than the 2 and the negative 2. Here I need the stuff in between, or my sandwich. Alrighty, maybe this idea makes perfect sense to you, or maybe it doesn't, and that's totally fine. But with this baseline idea, we're going to do some practice with it. Let's see how we can use it to solve some inequalities. So say I take the absolute value of 4p minus 7 is greater than or equal to 5. If it ain't broke, don't fix it. I want to solve this inequality. First of all, what do you think might be a good first move to make and why? Go. Alrighty. Well, here, just like when I was solving my equations, I knew what to do when absolute value was by itself. So my first move should probably be to isolate my absolute value. Or in other words, right, I want to begin by getting everything attached to the absolute value away, right? I want to get my absolute value by itself. So first thing I notice here is that negative 7 on the outside of the absolute value. Let's undo it using a positive 7. So I'll say the absolute value of 4p is going to be greater than or equal to 12. Now that I'm here, the next thing that I want to do, right, in this case, I found a way to break down the absolute value. Here, the way that I can break down my absolute value, right, if we scroll up real quick, we'll see that we can get rid of an absolute value by turning it into a compound inequality. So it will give me either a split graph or a sandwich graph, right? It's going to be either my and statement or my or statement. And the way that I'm going to determine that is based on the symbol. So as we see, if I have a greater than symbol, right, my greater than symbol matches with my split, whereas my less than symbol matches with my sandwich. So this graph, I see a greater than, that's going to need to give me absolute values that are farther away from 12. Algebraically then, right, I can write this. If the absolute value of the stuff inside the bars, right, let's call it x, is greater than some number a, this here is going to be my split. So I need to be on the outsides of the a and the negative a. So that would tell me here, right, either x needs to be to the right of the positive a, or it needs to be to the left of the negative a, right? Here's going to be our split. Alternatively, if I see that my absolute value is less than some number, this here, I know, will need to be closer to 0 than a. So I'm going to need a value of x that's sandwiched in between the a and the negative a. So a less than symbol or a less than or equal to symbol will give me my sandwich. So seeing this greater than symbol, this immediately should tell me I need to be on the outsides of positive 12 and negative 12. I need a split. So by breaking this down into my two cases, either the stuff inside the absolute value needs to be to the right or equal to the positive 12, or it needs to be to the left or equal to the negative 12. And from here, all I've got to do to bring it home is solve for my variable. So on the left, I've got 4p is greater than or equal to 12. Let's divide both sides by 4. 4 divided by 4, well, that's going to give me just 1. 12 divided by 4 is 3. So p could be greater than or equal to 3 on the left, or on the right, if I divide both sides by 4 again to isolate my variable, I would get that p could also be less than or equal to negative 3. Nice. I've got my solutions. And again, if this feels weird, that's amazing. Ride the wave. Sit in the discomfort. Let it wash over you. Find peace in your pain. Okay, all I want to do now, let's graph it and write our notations. See how much you remember. Take 30 seconds. Do you remember how to graph this compound inequality and how to write its set builder and interval notations? Go ahead. Okay, so I want to get p on my number line. In this case, right, for my compound inequality, I'll put my negative 3 and my 3 down. I'll label my number line with a p. Both of these have an or equal to. Both of them get closed circles. If I'm greater than or equal to the 3, right, I'm going to be to the right of the 3. It's a split. If I'm less than or equal to the negative 3, I'm going to be to the left of the negative 3. Fantastic. Let's write our set builder and interval notations. For set builder, again, we always start with our squiggle. Here, as much as I would like to, I can't use my shorthand because I've shaded in some stuff on my number line. So I'm going to use my more annoying, longer one. I'll say p is greater than or equal to positive 3 or less than or equal to negative 3. And for my interval notation, again, reading from left to right. So on the left, I went all the way off to negative infinity. I went up until negative 3. Has a closed circle, it gets a bracket. Negative infinity is not included, it always gets a parentheses. Or, right, I've got my space in between. I could be on the branch that starts at 3. It has a closed circle, so it gets a bracket, and ends all the way on the right at positive infinity. Nice. So let's do one more for the road. I've got 2 written down, but we'll just take the one on the left. The one on the right will be our opening problem next class. Negative 2 times the absolute value of 3 minus k is greater than negative 22. I want to take this guy, start by getting our absolute value by itself, figure out if I'm in a split case or a sandwich case based on my inequality, rewrite our inequality as a compound, solve for our variable, plot it on our number line, and write our notations. Give yourselves 3 minutes, see how far you get. Have fun, believe in you like I believe in you. Let's do it. Alrighty, so here, I want to get the absolute value by itself. My opening move, let's divide both sides by negative 2. On the left, these undo each other. I'm left with just the absolute value of 3 minus k is greater than 11. And then I move on. No, I can't. What happened? Well, I divided by a negative number, and when I divide by a negative number, what happens? I do a big old backflip. So I need to take my inequality symbol and swap it from a greater than to a less than. Now, the absolute value is by itself. I'm going to interrogate my symbol. I see a less than. What does a less than tell me? Well, I need the absolute value to be closer to 0 than 11. So instead of being at 11, I need to be closer to 0. I need to be on the insides of the 11 and the negative 11. This is going to be a sandwich. So I'm going to take my value of 3 minus k, right? It's going to need to be stuck between the positive 11 and the negative 11. And here, right, I don't have an or equal to, so both of the signs in my sandwich are going to get just a normal less than sign. Cool. From here, I just need to get k by itself. First thing I might do is subtract 3 from both sides to accomplish that goal. In this case, negative 11 minus 3 is going to give me negative 14. In the middle, the 3 and the negative 3 undo each other. I'm just left with negative k. And on the right, 11 minus 3 is 8. Last move, I've got to get k by itself. I have a negative 1 attached to it. I could either divide or multiply by negative 1 to get rid of that minus sign. But if I multiply by a negative again, what's going to happen? Well, I got to flip my inequality once again. So both of my less thans are going to become greater than. Negative 14 times negative 1 is going to become positive 14. I've got positive k in the middle and negative 8 on the right. Nice. On my number line, let's graph it. So I've got a negative 8 and a 14 as the outer bounds of my sandwich, my pieces of bread. Both of these do not have or equal to, so both of them will get open circles. And then the k is stuck in between these two numbers. I'm going to shade in the part of my graph that's in between them. My set builder notation, well, again, I want all values of k such that k is between negative 8 and 14. If you wanted to write it in that kind of inverted order above, that's totally fine. I personally always like to write it in ascending order, but that is just a preference. I'm dying. And then for my interval, right, I've got negative 8 and 14. So reading the part that I colored in from left to right, I started at negative 8. I went off until 14. Both have open circles, so both get parentheses. Cool. You know what? I am going to do the next one as well. If you're somebody who's like, cool, I got this, you can tap out of the video now. I'll see you next time. If you want to stick around for the next one, give yourselves another 3-minute timer. See how far you get. Your goal is to get the absolute value by itself. After that, we want to break it down into either our split or our sandwich, depending on our inequality, make our graph, and draw both our set builder and interval notations. Again, if you're noping out, you're noping out. I'll see you when I see you. If you want to stick around and get a little more practice, be my guest. Alrighty, let's do it. And I don't feel bad because the next video is going to be super short. So I want to get absolute value by itself. Let's start by subtracting 1 from both sides. That leaves me with 4 times the absolute value of 2n minus 3 is going to be less than or equal to 16. Divide both sides by 4 to get our absolute value alone. That leaves me with the absolute value of 2n minus 3 is less than or equal to 4. From here, again, I'm going to interpret my inequality symbol. I'm saying here the absolute value needs to be less than or equal to the 4. So is it going to be closer to 0 or farther from 0 than 4? 5, 4, 3, 2, 1. Well, if I want something less than 4, right, it's going to need to be closer to the 0. So I'm going to be sandwiched, once again, between the positive and the negative 4. So rewriting this as my compound inequality, 2n minus 3, the stuff inside the absolute value, right, it needs to be closer to the 0 than the 4 and the negative 4. So it's going to be sandwiched in between them. And I've got an or equal to, so I'll write my or equal to symbol as well. And from here, all I've got to do is get n by itself. Let's start by adding 3 to all 3 parts of our compound inequality. In the middle, they undo each other. I'm just left with a 2n. It's less than or equal to 7 on the right, greater than or equal to negative 1 on the left. Last move, let's divide all 3 parts by 2. That tells me here that n is going to be greater than or equal to negative 1/2 and less than or equal to 7/2. Magnificent. On our number line, I'm going to take my negative 1/2, my positive 7/2. I've got values of n, right? I could be equal to, so I've got closed circles around both. My n is sandwiched in between the 2 numbers. I'm going to color in the stuff in between on my number line. Last but not least, let's write our notations. I've got my Smash Bros and my interval. Set builder notation, right? I'm interested in the values of n such that negative 1/2 is less than or equal to the n, which is less than or equal to the 7/2. Interval notation, again, reading the part that I shaded in from left to right. Started at negative 1/2 on the left, went off to 7/2 on the right. Both of them have closed circles, so both of them get brackets.